All that came out was 2 drops. You see, I was expecting quite a bit more bleach to come out than that. However, it seems that we've only achieved 2 drops. How did we get to this point? Well, that question starts at 9 AM on Sunday. So after the failure of our previous partitioned cell experiment, it was time to scale things up. As you see, that experiment was not just a failure, and it did show some promises of good results. However, the main issue with it was that we did not have enough surface area of our membrane. So to increase our surface area, I opted to add more membranes. Now these guys had sat much longer. They had been in the fridge while we were doing our previous experiment, and I had pulled them out. Of course, the membrane from last time is still in service for this experiment, as I notice no signs of degradation or anything like that. Now you may say, isn't this painful hitting it with your hand? Well, I don't care. In fact, I didn't even think of it at the time, and I'm only now thinking about it. Let me introduce you to one of my favorite tools. I call this pipe scissors. This pipe scissors device cuts through pipes like it's absolutely nothing, and it's like butter. There is one slight issue with this device, that you'll never ever get a straight cut because the PVC bends. Maybe next time I should invest in polytetrafluoroethylene pipes. That might be quite interesting. Maybe we could get some. Also, you're probably wondering why PVC pipes, and the answer is because PVC pipes are actually used in some industrial settings and are fairly inert, and probably won't react with any of the stuff we're messing with today. I actually prepared both solutions off-site. One side, of course, is going to be running salt water, but it's going to be super saturated with salt and barely any water. This was a bit of a mistake, as you'll see later on. And the other side, of course, is just going to be pure water. Though none of my water is actually distilled, it's straight from the sink, which is a very big mistake, and we're going to be changing that next weekend. So after some setup, I was able to get the partitioned cell mounted to the cinder blocks, and was able to get it functioning, up and running, and you can even see it later on in the video. Once it gets really going, it's running. It's really running. Like last time, I noticed some bubbles. This time, I noticed there was just bubbles. Pure bubbles. So many bubbles. However, very early on, I noticed something very dangerous about this setup, and it does come into play later on. Let's just say that the introduction of so many new pipes has created quite a few more failure points. So early on, as to whether or not it was actually reacting is quite questionable, as you can't really see what's going on. However, what I believe happens here is that it's basically going very slow at the start, and as more sodium ions are pulled across the membrane to the cathode, then more stuff should happen on this side, and the formation of sodium hydroxide should occur. Which indeed happened, although it got destroyed at some point, and it did not end up being sodium hydroxide. Although I still have the solution, and I'm really not quite sure whether or not it's actually sodium hydroxide or not. Although I did have one successful test on the tinfoil where it actually kind of did something, but like barely anything. So if it was sodium hydroxide, it was not very concentrated, and the way to concentrate it would be to boil it more. Although that will be a video for another time, if we ever do get our hands on actual sodium hydroxide solution from this. Now, like I said before anything was sodium hydroxide or anything, it was leaking. And this was just water right here. The thing was just straight up dripping water. Which, it was only leaking from one place on that site. And I don't even remember which part it was. I think it was like right at the bottom. No, I should have been wearing eye protection when looking down this tube. As if any sodium hydroxide was in there, and any gases, the gaseous hydrogen rising out could actually cause it to, tiny droplets to splash out. This is something I have noticed in previous experimentation. Anyway, I eventually removed the T-section pipe, and we could finally see inside what was happening. So the cations in solution are hydrogen and sodium. The sodium is crossing the membrane from the anode cell, and the hydrogen is present in the water in the cathode cell. The electrostatic force from the cathode pulls the wonderful sodium across the membrane. Now at the anode, chlorine gas forms, and again, hydroxide ions from the cathode cell are going to attempt to be pulled across. But here's what I think happens. is that while some hydroxide crosses and some sodium cross, they mostly meet somewhere in the middle on one of the sides. And when a sodium plus meets with a hydroxide minus, you get a compound called sodium hydroxide. The tube was actually leaking so rapidly that I would have to refill it every now and then. And in fact, there was a substantial amount when I did have to refill it. Probably like 7 or so milliliters. Now at this point, you can see how many bubbles there are. There's a lot of bubbles in that solution. This is the most we've ever seen with any of our partition cell experiments, and we've only done 2 now, but this is very successful, considering that the next video I have is absolute garbage. Oh my gosh. The next video is mostly just experimentation with what we can use for membranes. Because I had quite a few ideas, and I want to experiment with polymers, because polymers are a good idea. I'm actually quite surprised with how many shots I got of it, with all of the bubbles forming on this side. Now, I also want to explain here that the reason we're using copper and the same electrodes as last time, basically, is because I did not think there would be any problems with that. However, we do find out later on there were some problems with that. There was some problems with that. Yeah, we should have not done that because, well, you'll see in a bit. Now, on the anode tube, there was a major issue. It started to also leak, and it was leaking upwards where it should not have been leaking because it was not that full. Somehow it filled itself, or something. Or maybe the chlorine bubbles got to it and it just decided to go up. But you see, this is the beginning of the end, because this is where the bleach is just leaking out of it. Listening very closely in this next part, you can actually hear the bubbles. I did not hear this at the time, but you can hear something sizzling. And this sounds very beautiful. However, very problematic is the fact that it's actually turned orange. Because the electrode has begun to dissolve. For some reason, I think our copper electrode gave up on us. Maybe we ran too many volts through it, or maybe it reacts with sodium hydroxide. Either way, electrode is done for. It melted. Now that's a non-issue because I have a practically unlimited supply of copper wire, so I could just make another one. However, I want to make graphite ones, which is going to take a lot of work. Anyway, at this point it was time to dump it, which I should have been wearing gloves because I did manage to get some of this wonderful liquid on my hands. Thankfully, I still have hands. Now don't ask me why it's so dark and why it looks like iron oxide solution. This is strange. Anyway, if it's your first time here on this channel, I hate copper oxide, or orange juice as I like to call it. This stuff goes straight through filters. Of course, my filters are like the worst filters in the world. It's literally just a tissue. It's very annoying, and it turns blue, and it looks disgusting. Remember the fact that that pipe was leaking? Well, it's come back to bite us already. You see, all of the liquid in there, at the time I did not know this, but now I do, all the liquid drained right out. It just went straight out the pipe. Straight up. It defied gravity. This also just left a gallon of salt in there. A lot of salt. Not a gallon, but like, you know what I mean. And I really was not sure what was going on with this electrode. It looked like it was working perfectly fine at the time, so I just kept it in there, but it seemed to stop working. Which I should have known. I should have just dumped more water in there. More water. It needs more water. Are you ready to see what copper cathode sludge is like? Well, let me go ahead and demonstrate by filtering it. You see, you would expect to get something useful out of this if it was iron cathode solution, but no, this is copper. It goes straight through the filter. And this is why I call it orange juice. This is not copper oxide solution, of course. What I think this is there's, because of how the cathode is just being destroyed, I don't think it's actually oxidizing. I think it's just falling apart. Like, I think that's what's happening. I don't understand what this is or how it exists. But I still have this bottle, and I think in a future video we'll do something with it. Maybe nitrate it. I don't know. Of course, that's months down the road because we still have to do the ammonia video, and then we have to do the other video, and then we have to do another video, and then we have to... There's a lot of videos between us and there. But we have a lot of processes to do to get to that point where we can actually do anything with this. It smells like battery acid. It smells very toxic. Daylight was running out, and the second batch of liquid has become orange juice again. This is how they make orange juice, by the way. It doesn't come from oranges, it comes from copper wire. And it's not pulp-free, it's all pulp. And the pulp is actually just copper. Anyway, I didn't actually get any of the tests in the video, but yes, we do test it a lot. I tested it every time I would come out there. I would go take a little bit of the solution from the cathode side and test it. I tested it with vinegar to determine if it was actually basic or not, which I don't think does anything. Really, if I wanted to test it, I would need hydrochloric acid, which we still haven't made that. We still need to make that. But this is how we would make it, is that we take the hydrogen and the chlorine we get, and then we just shove them together and put a little UV light in it. It's just good. Or you can light them on fire. But I've actually ran out of UV light, so we won't be able to make that for a long time. Alright, now we have to open up this valve and watch what comes out. It appears to be much less cuprous than the last one. But it's still definitely contains some of the copper. In fact, in much larger particulates. Anyway, since we'd ran out of daylight, it was basically time for us to clean up the whole thing and take a look at what happened. And surprisingly, or well, not so surprisingly, we just had a bunch of salt in one of the tubes, and barely any of the wonderful substance known as bleach. I honestly did not expect this and did not understand it at the time, but then when I looked in at it, and I put two and two together, we should probably have put a little bit more water in there. Like half of it should have been water, and half should be the other stuff. But you still need some that's not dissolved, because it gets dissolved as the sodium passes through the membrane. So the bleach we recovered from this did contain some kind of metal oxides or something in it. It was a powder of some kind. This is characteristic of most of the bleaches we've made, and in fact, this setup actually produces bleaches that are very concentrated. Like, if you do it normally with just like having the electrodes together, you do get a bleach, but it's not like as yellow as it is when you do it this way. You get like very yellow and very smelly. In one of my very first experiments, I actually made iron oxide solution, and it was definitely a bleach, but it was much less concentrated. However, this machine, this device, this abomination produces yellow. I can only attribute this to the fact that the membrane does a very good job at isolating the reactions on both sides, so that way you don't have a million side reactions going off, but rather maybe one or two every once in a while. You end up with a very pure solution.